Today we're going to be reprogramming the odometer after a cluster swap on a Honda Accord. This is going to be a do-it-yourself at-home hack that you can do in your basement with no special tools. This car currently has 314,622 kilometers. And here I've got my new cluster swapped in. It has only 211,150 kilometers. So I need to correct this to match the mileage of the vehicle. Now the odometer information is stored on a chip behind the gauges, so we're going to need to take it out. I'm going to first start by removing these two screws here, and then we can go ahead and pop off this bezel. And then there's two more screws, one on each side, as well as one to remove from the top. Then I can go ahead and reach in and pull out the instrument cluster. So here I've got the cluster pulled out of the vehicle. There's a couple of tabs here on the bottom to undo, as well as some tabs here at the top that we undo, and then we can pull off the glass fascia. Then a couple more tabs here, and we can remove the hood from the cluster, and then this ring just pops off. And here's where it gets a bit tricky because the chip is actually stored underneath these gauge faces. So the first thing you're going to want to do is take a picture of the position of all of these gauges so you can put them back on in the correct order. You're going to want to use gloves when you take them off because this surface here is very prone to fingerprints and you can't really clean that. And then pull up really hard and the needle will come out. And before we take the cluster off, you have to take this face off. There's a little ring here that snaps off the middle. And once all the tabs are loose, we can remove the backing plate. This here is where the chip stores the information for the odometer. If you zoom in here, it's actually an L56 EEPROM chip. So if you flip this board over, on this side here you can see that there's some contact soldering points that we can solder our wires to for programming. So to make sure I got the wiring for the chip properly, this is the top of the chip here where the dimple is. That's pin 1. What I'm going to do is use my continuity tester to test all of these pins over to the appropriate soldering points over here where I can connect my hookup wire. So I've traced the EEPROM wires to pins 1, 2, 3, 4, 5, and pin 8 down here. So here we're soldering the hookup wire to the EEPROM chip on the back of the board. Alright, so here I've got all 6 wires soldered to the back of the board, connected to the EEPROM. Next I'm going to connect it to my PC. This here is the programming circuit I'm going to be using to connect the EEPROM to the serial port on the computer so I can read and write to the chip. There's about 6 wires here that it connects to. It goes through some 4.7k ohm resistors as well as some Zener diodes before going out to the chip. Now pins 8 goes to 5 volts and pin 5 goes to ground. So here's my overall setup here. I've got this state-of-the-art Pentium 4 computer with a serial port that goes out to my breakout board, which has my EEPROM reading circuit on it with the resistors and diodes. And then that goes out to my odometer, which I soldered the wires to the chip. You'll also have to short the crystal to get the software to read the chip. The software I'm using is called PonyProg, which is a serial device programmer. The first thing I'm going to do is go to Options and click Setup, and make sure it's set to read from the serial port, SI Prog IO, and COM1. We can also probe to make sure that it detects your serial programmer, and then click OK. Next I'm going to head over to Device and select the microwire EEPROM 9356 chip, which is the closest chip that matches the L56 on this board. Then over here on the left side I'm going to click Read Device, and it will download all of the information on the EEPROM chip. Now you'll notice here that the chip stores information in hex in a 16 by 16 array. So I'm running into a little problem here. When I try to click write to the chip and I click yes, it gives me a problem saying device is not responding. Now that's because the EEPROM is still connected to the dashboard. So because we can't write to the chip in circuit, we're going to need to disconnect pin 1 to pin 4 on the left side there from the board. So we're adding a little bit of solder to make it easier to suck up the solder from the pads. Alright, now we're going to suck up the solder. Shit. Okay, so we broke the EEPROM chip. We're just now going to desolder whatever's remaining of it so we can put it in a replacement later. Alright, so my old chip is pretty much garbage. The leads are broken, but luckily I found a new chip. It is also a 93C56 EEPROM chip, which is compatible with this board. As you can see here, it's still soldered onto its original board, which was actually an ECU from a car, and I've soldered some hookup wire so I can connect it to my circuit. So since I've already downloaded my odometer information from the old chip, I can then use my EEPROM reader to edit that, and then write that to the new chip while it's still disconnected from the board. Now the added benefit of having the EEPROM separated from the odometer board is I can go back and forth between the car and my programmer and decode the hex dump, and then solder this to the new board so I can get the corrected odometer reading on my new cluster. Alright, so we're back at the hex dump here. What you want to pay attention to is these bottom 2 rows. That's where the odometer information is stored. You're going to see here 3385 CC7A repeated 8 times. Now if we pull off the hex program and try to decode it, you'll notice that the major part of the odometer reading is stored in these bottom lines here, and that reads 3385 CC7A. There's also a minor part to the odometer reading that's in line C, and lines A and B store the information for the trip computer. So how it's formatted here is we've got a major and a minor hex value that gives you your total odometer reading. Now the minor value is like your ones and tens column, it's an incremental value that goes up. And then we've got your base value, which is like your hundreds and thousands column, which is more important. So we're going to focus on programming that more to give you your total odometer reading. So if we take a closer look at the odometer dump 3385 CC78, you'll notice that CC78 is actually the inverse of 3385, and this is like a checksum. What that is basically the hex lookup table from 0 to F and from F to 0 inverted backwards. So if you look here, 3 is the inverse of C, 8 is the inverse of 7, and 5 is the inverse of A. So basically your odometer reading is just stored in these values over here. In order to convert this over to odometer reading that we can understand, we're going to take the 3385, which has a base of 16, and convert hex to decimal, which will give you 13,189. Then we're going to go over and multiply that by 16 to give you your final odometer reading of 211,024 kilometers, which is close enough to what we have on the vehicle. So now say I have 314,000 kilometers on the car and I want to convert that. I'm going to work backwards. First divide that by 16. That gives me 19,663. Then I'll convert that over into hex, which gives me 4CCF. Then I'll need to find the checksum of that, which is B330, using the hex lookup table. This total value of 4CCF B330 is what I'll need to replace in the odometer dump and then write it to the chip in order to reprogram the odometer. So in order to edit the information on the chip, I'm going to go over to the edit menu and click Edit Buffer Enable. And then I'm going to go down to where the odometer information is stored, 3385 CCA, and click on each bit and change the information. So I'm going to change 33 to 4C. I'm going to change 85 to CF, and CC to B3, which is its checksum, and 7A to 30. And then I'm going to repeat that 8 times across all of the bottom lines. Alright, so I've used the edit buffer to change all of the bottom rows from 3885 CC7A to 4CCF B330, repeated 8 times across the bottom. I can then go over to this button here, which will write it to the EEPROM, click yes, and it will write that to the EEPROM. Now that I've wrote the new odometer reading to the EEPROM, I can go ahead and disconnect all my hookup wires from my EEPROM circuit, and then I can use these hookup wires to connect to the odometer board and go test it out in the car. Alright, so here's my odometer board. I still have the hookup wire hooked up at the back. I've just used some alligator clips to connect my EEPROM chip to the bottom here so I can test it out in the car. I'm going to go ahead and insert and turn the key. And as you can see, the kilometers have now changed to 314,543 kilometers, which is close enough to what I had on this vehicle. You can also see that this is an EXL cluster. When I click the button, it's got the outside temperature option, which is now an option I can add to my car with this new cluster. Alright, so now that I've verified that the odometer works with the new program, I'm going to now solder the new chip back onto the odometer board into the spot where the old one was. Alright, so now I'm desoldering the donor chip from the ECU board. Alright, so now we're going to position the new program chip back onto the board, and we're just tacking that chip down there. So this wire that's hanging off pin 2 here was one of the pads that broke when we were removing the old chip. It's highly recommended that you use a hot air station when removing these chips because it's pretty difficult to remove with just a soldering iron. Alright, so now that we've got the odometer program with the new odometer reading, we're going to go ahead and reinstall this back into the instrument cluster, and then we're going to reinstall the upper gauge face. Again, you want to avoid putting your fingerprints on this matte material because you won't be able to get it off even with rubbing alcohol. And then we're going to replace the speedometer face. Next we're going to reinstall the speedometer needle. Just going to bring that in and line it up, and then it should be free to move. And you'll notice that there's a stopper here, so we need to adjust it so that now it reads 0. Next we're going to replace the hood, and then of course the plastic cover. Alright, we've got the new program cluster swapped into the car. I'm going to go ahead and start it up. Now of course you can program anything you want on your odometer. In my case, I programmed it to 999,999 kilometers. Remember kids, while it's not illegal to reprogram your odometer, it is illegal to misrepresent the mileage when you're selling the car. Now with 1 million kilometers, I can go over to my local Honda dealership and trade it in for a free, brand new Honda Accord. Hey guys, check it out, it's my new Honda Accord. Make sure you subscribe if you want to see more videos.